Good
First
timing.
covered
That is the biggest surprise, is how much it draws.
Water supply for much of the area, and I went out and I'm taking care of the rest of the resort area, and just I want to give you a little insight. I don't want to go too deep in depth. Kurt's model is pretty detailed, extensive, and interesting, but I just want to give you a little idea and get the highlights of kind of what we're working on for the rest of the resort area. So this is just give you an idea of a 3D graphic image of, and the colors are the different geologic formations here. They're all tilted and folded and standing up on edge. A lot of them are dipping this down into the valley and then up against the North Ridge over here. Next. So, and also there's a lot of structure here. The red lines are folds in the geology, and the black lines here are major faults and structures. So there's a lot of that, and then of course the road, some of the basic road system here, just give you an overview of what's going on. The green part's the frontier formation, which is mostly a shale and a sandstone that's near the surface. Sandstone lenses within thick shale sequences, and that's pretty prevalent around the surface of the area. Andesite Ridge is a big fold right here. Yellowstone Club right down in here. Moonlight back here. Just to give you an idea of different places we're looking at. This is all the wells that we monitored for the 2-year period that we were up here. The black ones are just ones we hit every month with hand measurements, and the green ones are ones we put the data loggers in that recorded water levels every hour. So we have quite an extensive record of data for the whole system throughout the year, every hour. Sorry.
No.
So one of our students that we had working with us early on took some of the early water quality data, and she collected all the information that we had in the database before we started our work, and took a look at the water chemistry. And these are called stiff diagrams, and they indicate different minerals within the water and the concentrations of those minerals. So there's calcium, magnesium, sodium, potassium, bicarbonate, sulfate, and chloride. And it just gives you, that's just the main ions in the water. And the different shade indicates a different concentration, and a different color indicates a different aquifer. There's several layers of geology here, and some wells are completed in the frontier, some in the muddy, some in the Kootenai, which is a very common aquifer here. And so this gives you an idea of just how the water chemistry differs across the area. The yellow ones here are the springs of the Madison Formation, so that's the quality of the Madison water. You can see narrow symbols mean less mineral concentrations in those waters, so a little bit clearer water. And the high bars out here like this indicate a higher concentration of those minerals. So we also looked at isotopes of water, just different atomic elements of the water itself, and those help us. We looked at oxygen 18 and deuterium, which give us an idea of the source of the water. Higher elevations have a different signature. Then here's some snow samples we took, and here's their concentrations. Here's some rainfall we took, and there's their concentrations. And you can see the wells and stream water kind of fall in between. The line is kind of an average trend throughout the world of what these concentrations should look like. So we're using these to kind of date where the water's coming in and going out. We also did tritium analysis, which the tritium was a hydrogen, 3 hydrogens in water that was formed during atomic testing around 1960. And you can test for the measurement of that concentration, and that will give you an idea of the age of that water. Was it formed around then? Was the water in the ground before that time, or has it entered the ground after that time? And so that stuff's all very interesting, and we're finding some really good stuff about ages of water here. Next one. Here's the other thing we're looking at is the Madison Aquifer. And so Mike Richter here has a well down here at Red Cliff Campground. We have the springs of the Madison Formation here. We have some other wells that came close, the Blue Grouse well, a couple other wells in the neighborhood. We have one that was drilled over in Beaver Creek last year. Potts Drilling did one down into the Madison. So we've got all that water information, and we're going to try to give you guys some idea of what's known about the Madison Aquifer and what the potential might be, or some things to consider for when it comes time to, if you want to drill for that.
Do you remember, James, how deep that Madison well was in Beaver Creek? It was it's over 1,000 feet.
1,700.
1,700.
Yeah.
It was the deepest one in the state.
1,400.
Yeah. which isn't.
It was impressive.
You know, and everything's kind of sloping this way, so water
Is it
flows
hot?
from that area down here. And so you have a very low water level here. We can compare that to some water levels down here. We'll have all that for you on the information. But yeah, Mike sampled that, so we have water quality information from it. I think he did some age dating, but that might take a little while to come through. And so we'll have some cross sections, we'll have some chemistry information, we'll have some flow information and water levels for all that. So that's still kind of coming along. So the other thing we did was measured with these hourly water level measurements. We looked at each of these wells, and I'll just show you an example of one little area I'm working on. Moonlight Basin, here's Jack Creek Lodge. Here's just a unused well on the other side of the divide, and then a well down halfway down the mountain and then down below the golf course. So to give you an idea of what the water levels and seasonal changes in those water levels are like compared to snowfall, precipitation, and stream flows. So you can see here the dotted one, the gray one, is Jack Creek Lodge water levels, and it's a pumping well, so there's a lot of interference from the pumping activity, and that's why it's so spread out. But the top of that curve gives you an idea of kind of the natural water level changes through the season. The green one is that unused well just across the divide, about the same elevation, 8,090 feet. Unused well, so it's pretty quiet over there, and that gives us a real good idea of water level changes in the system. But you can see here, water levels are here, and this is just a measure of feet of change. You can see it went over 45 feet. It went down below our data logger. So it changed over 45 feet through the winter, and then in the spring, it starts recharging. The orange line is snowfall, snow accumulation at the snowtail site. And so you can see the snow is building up and accumulating. Then around the 9th of April, you start seeing the snow melting off. And so as the snow melts off, this gray area, snow melt period, you can see that the water levels start rising in the wells almost instantly, which is a good indication of a strong connection between the surface and the groundwater. So you can also see there's another blip here around August, and I'll show you October, September and October, and I'll show you that in a minute. Here's 2016, same thing. Water level rises and then declines, and following that, closely this well at the Jack Creek Lodge and this well across the divide both show a similar pattern to how the snow melt happened. So snow melt, very spiky and builds up and then drops off quickly. The stream flows do the same thing, and also a lot of these water wells do the same thing. And this well is several hundred feet deep as well. So, next one. So this is precipitation measured from the weather station here. The other thing that to notice here is big rainfall events, and you can see that the water level has a little kick there. Here's 3 days of rainfall that amounted to, I think, 1.7 inches of precipitation over like a 3-day period. And all of a sudden, the water level in the well comes up and then drops off. Same thing over here. You can see these little flattening or the reversing of the water levels are shows the change in the water level. So it shows this rather good connection in some of these wells. They're not all the same, but that's what we're looking at here. Next one. So just to give you an idea, that well on the other side of the divide from Jack Creek Lodge, it's got some of the day side in it, which is the Lone Peak intrusive. And if you look at the rock glaciers, it's all kind of shattered and broken. It makes a great aquifer for water flow, and that really allows a lot of water movement. So the wells screen a little bit in that, and then also in some shales and sandstones, which again have been tilted up and folded. So there's a lot of fractures and cracks in those, so the water moves fairly freely through those. And as those water levels show, there is a great connection, especially right at the divide where you go over to Moonlight, because the geology is tilted up on edge, and the water you can get into is top flowing along the fracture systems. So the other area I looked at was then the next one. So we looked at these two wells. So we'll move farther down the ridge, and we'll look at this well. It's about halfway down the ridge towards the golf course. So you can see this one's got a little bit different shape to it. The other well changed over 45 feet. This is only about 20-some feet of change in the water level here. Again, you can see the snow, as the snow melt came off. We'll look at the snow in a second, but you can see precipitation here. You had another big kick. You also have little bumps every time there's a rainfall event, so there's a strong connection, but the water level change isn't quite as extensive. That has to do with the amount of water that gets into the system, and also the nature of the geology and how much it can take in and store.
Is that the well that is used for irrigation of that golf course, or?
No, this one's below the, you know where the gravel pit is?
Yes.
And it's between the gravel pit and the main road, so it's
Okay.
on your way up to the gravel pit.
So it's that last well that is the irrigator for the golf course?
No, this one's unused, it's just
Okay.
sitting out there, you drive up the road to the gravel pit, it's
Yeah.
about halfway up, just sitting right next to the road.
Okay.
And then they got the gravel pit well as well, so this is a good one, again, quiet, nothing going on there, so we're just collecting natural water level changes. This well is the well down below the golf course, way out beyond the golf course to the south, over towards Fan Mountain. And you can see down here, the water level changes very little. It's 7,580 feet. Also, the geology is flattening out a little there, so you have to go more through the shales into the sandstones, maybe less disruption. There's also a big structure that runs through there that may form some clays and block some of the water flow. But you can see a much more subtle and a much more delayed response to snow melt and no blips for precipitation events. So less responsive down here too. It still receives water, but it doesn't receive it this quickly and suddenly. So again, here's that same well back up on the hill, and the snow melt starts, and within 4/9, the next day, you start seeing the water levels rising to the peak at 4/29, back down by the end of May, and getting down into more of a base flow period here where the water levels stay pretty stable throughout the year. Again, snow melt 4/8 reaches a 4/9, it starts rising. 5/11 to 5/25, you get probably just weather events and snow melt and precipitation timing that causes the irregularity, and then 5:30 you're back down to a base flow again. So a lot like the creek you see out here, it behaves the same way. Here's what Kirk was talking about with the snow accumulation down here in the meadow. This snow is up at Lone Peak at over 8,000 feet. This is down here at the meadow. You can see the snow building up on that river gauge on top of the ice. And then you can see here at the 17th, all of a sudden it breaks out, the snow's gone, and then you're back to the stream flow. Stream peaks on the 11th and then drops off to a base flow as well. And again, down here below the golf course, there's this more subtle and more delayed 4/9 versus 7/6 in July it reaches the peak. So much more delayed, much slower response, still getting recharged though. Next one. So I think that's about it, but essentially a few pros and cons, good recharge every year, but it's highly vulnerable to surface influences, and if you have some dry years, that may affect some of the wells and some of the water levels as well. So, and we're doing this all over the resort, so we'll have different areas and different responses to be able to compare them.